So today we're going to look at how to find acceleration using a velocity time graph and a position versus time graph. Let's start with the velocity versus time graph. So we start by drawing our x and y axis with the time on the x-axis in seconds and the velocity in meters per second on the y-axis. And then we can draw a graph with our 2 points corresponding to t1 and t2, as well as v1x and v2x. So we can start with the average acceleration. So for the average acceleration, we have this equation, change in velocity divided by the change in time, which is the same as v2x minus v1x and t2 minus t1. So graphically, the average acceleration is just the slope connecting the 2 points, p2 and p1. So on the graph, if we label P1 and P2 and draw a line connecting P1 to P2, the slope of this line will be the average acceleration. Now we can look at how to find the instantaneous acceleration graphically. So a quick note on the instantaneous acceleration. So the equation for it is equal to the limit as delta t goes to 0 of the change in velocity over change in time, which is also just the limit of the average acceleration as delta t goes to 0. So if we look at this graph here and we draw P1 and P2 and the slope, the instantaneous acceleration is just the slope when delta t goes to 0. So basically, when we're bringing P2 infinitesimally close to P1, it ends up just being the tangent of the graph at that point, as you can see me drawing it below. So to find the instantaneous acceleration at any point, you just have to draw the tangent to the curve. And in the next video, we'll look at how to find the acceleration from a position time graph.